In looking at how to solve the sum of three consecutive integers, it's much the same strategy as three consecutive odd integers or three consecutive even integers. There is a slight difference if you're talking about consecutive versus odd or even. But we'll get to each of those. Since there's three of these integers, I'm going to use three boxes to indicate that. So here's my first one, my second one, and my third one. And if I add them all together, I get 657. So for the addition, I'll indicate that with something that's quite familiar. All right. And keep in mind, this box here, this is my first, my second, and my third. All right, so I just like to use a box to represent each integer since I don't really know what else to do with it presently. And what we're going to do is we're going to specify that x is an integer. We're going to... Okay, so we'll say x is an integer. We have no idea of its value. I'm just going to put x in here. If you think about it, if I'm standing on an integer and I want to get to the next integer, I would take that integer and I would add 1 to it. That would get me to the next integer. And again, if I'm standing way back here on an integer and I want to get over to here, I'm going to have to add 2. So if I add the first, second, third, I'm supposed to get 657. So we'll do that. Here's our x. We're going to add that to x plus 1, and we'll add that to x plus 2, and we're supposed to get 657. Now we're going to solve for x. Keep in mind there's a 1 in front of each of these. Okay, so when I combine like terms, I get 3x. When I combine the 1 and the 2, I get a 3. So 3x plus 3 is equal to 657. Now we just solve the algebraic equation. Get rid of your 3. And now get rid of this 3. So I think I'll just slide this up a little. And you figure out that x is equal to 218. All right, but you're not finished yet. You figured out that x is equal to 218. So you take this 218 and you plug it in to your first box. All right, and lo and behold, no big surprise, your first integer is 218. You do the same for each box. You take your 218, you plug it in where x is, 218 plus 1, that's 219. And then you plug in 218 here as well, 218 plus 2 is 220. If you add these three integers, you will get 657. All right. So again, your first integer is 218, your second integer is 219, your third integer is 220. We'll look at the sum of two consecutive integers now. And they might refer to this as pages in a book. Okay, I could have 2 pages in a book that would add up to 519. Since there's only 2 of them this time, I'll only need 2 boxes. If I add them together, I'm going to get 519. I'm going to say that x is an integer. So I can just plug in an x here. You know, I think I kind of like labeling these boxes. We have 2 consecutive integers. So let's call this our first, and this is our second. All right, so if the first one we're just going to call x, to represent the second integer, we're going to need to add 1. So now if I add this box, I'm supposed to get 519. So that's where we get our equation from. X, I'll keep our red plus sign here. Plus x plus 1 is equal to 519. Remember, there's a 1 in front of each x, so when I combine like terms, I get 2x plus 1 equals 519. Now, get rid of this 1. And we have 2x equals 518. Now get rid of the 2. And you get x equals 259. Now you've figured out x, but you don't have your answer just yet, okay? The first integer, x, is right here. So 259, it might seem kind of silly, but I'm just kind of getting you used to plugging in values. X is 259. So your first integer is 259, okay? For your second one, you plug in 259 right where the x is. 259 plus 1 is 260. If I add these 2 integers together, I will get 519. So the first integer is 259, the second integer is 260. All right. Now this is a little bit different than consecutive even integers. All right. So notice when we had consecutive integers, we only had to add 1. For consecutive even integers, it'll be a little bit different. I have 3 of them. So I'll use 3 boxes. And it says the sum of them. So if I add the first, the second, and the third, I'm going to get 528. And again, let's label these. First, second, and third. And now instead of just saying that I want to use a variable x, okay? I don't know the value of this first integer. I'm just going to call it x. So I'm going to say x is an even integer. All right, so for the second integer, it's described in relation to the first. But if the first one is x, and think about this, if you're standing on an even integer and you want to get to the next even integer, you're going to have to add 2 to the first one. So this would be x plus 2. And again, just think of that briefly. If I had let's go with 14, how would I get to the next even integer? That would be 16. I would have to add 2 to get there. All right. I have no idea what x is, but except that it's an even integer. So I add 2 to get to the next one. All right, we don't need that for what we're doing. And again, x is my first integer. So to get from here to my third even integer, I'm going to have to add 4. So if I take my first integer, add it to my second integer, and then add that to the third integer, I will get 528. All right. Now I'm just going to combine like terms and solve for x. And again, keep in mind there's a 1 in front of each of these x's. All right. I don't have to write it. It's always understood to be there. So combining like terms, 1x plus 1x plus 1x, we have 3x. The 2 and the 4 gives us a 6. And this just drops down. All right, let's get rid of that 6. Three x 522, and then we'll have to get rid of that 3. So we end up with x equals 140 well, I think it's bigger than that. Let's be careful. So 3's going in there 7 times, right? And then a 4. Got a little early on my 4 there. So that's 174. We've figured out what x is, but we still have to plug it back in. All right? So you take your 174, you plug it in where x is, and obviously out comes 174. So that's our first integer. Take your 174, plug it in where x is. So 174 plus 2, 176. That's our second integer. Take your 174, plug it in where x is. 174 plus 4 is 178. So that's our third integer. If you add up these three integers, you will get 528. And you might be surprised that if we're looking for consecutive odd integers, you actually use the same arrangement. You might think, well, wait, 2 and 4 are even numbers. But remember, on this problem, I specified that x is an even integer, and that's what got the ball rolling. Okay? For this problem, I'm going to specify that x is an odd integer, and the next odd integer is 2 integers away. All right, so we'll solve the last one. So we have 3 consecutive odd integers. We'll use 3 boxes. And if we add them together, whoops, we will get 597. And again, I like to label these boxes so I can kind of keep them straight, especially when the problems get more complicated. So this is our first, our second, and our third. And we're going to specify that x is an odd. All right, so long as x is an odd integer, my first one, I have no idea what it is. I'll just call it x. The next one is x. If you're standing on an odd number, let's think of an odd number like 13. To get to the next odd number, you would add 2, and that would be 15, right? So you're just going to add 2 to x. Again, we don't need those. So to this x, I'll need to add 2. And then finally, for the third integer, x is way back here. So to get from this integer to this one, we'll have to add 4. So now if I add these 3 boxes up, I get 597. So we have x plus x plus 2 plus x plus 4. And now we combine like terms, solve for x, and we'll be all set. Remember, there's a 1 in front of each of these, so that's 3x. Adding the 2 and the 4, we get plus 6. Now we'll get rid of the 6. Get rid of the 3. And we get x equals 197. So we figured out that x is 197. We take that value and plug it in where the first x is. So our first integer is 197. We take the 197 and we plug it in here. 197 plus 2 is 199. That's our second integer. And again, we take 197, we plug it in right here, add 4. We get 201. That's our third integer. If you add up these 3 integers, you get 597.